Okay, so talking still about op-amp circuit design. One thing that we did not talk in class was how to add constant voltages to design problems or to the answers of the design problem. So I came up with a question that looked simpler, but at the end it sounded really weird. So I would like to go over this in video. Design a circuit that does a function, so f, and it's not f of x because it's f of a constant, so it's 6 minus 4. So of course you could say, look, I'll just give you 2 volts. But instead I want you to make a circuit. And it says you only have a 6-volt battery and a 4-volt battery. But you can use them in any way, which means you can put them, you can ground the positive side, or you can ground the negative side. And then use 1 op amp and only 10 kilo ohm resistors. The immediate design that comes to mind is a difference amplifier. And the difference amplifier would do the 6 volts on the positive input and the 4 on the negative, and do one minus the other, and we would use for R1 and R2 or Ri and Rf all 10 kilo ohm resistors. And this is the design. That's a traditional configuration that we have learned in class. So on the plus, we would put the 6 volt, and on the minus, we would put the 4 volts. And then all resistors are 10K, so you don't really need to label them, but I'm gonna label them just for. So this circuit here does 6 minus 4 times RF over RI, which is 1. So in the end, I would have F equals 2 volts. Now, a second design solution to these constraints is to make a summing amplifier that has minus 6 as input and 4 as input. So let me try that one. Maybe on this side. And again, it's only 10K resistor, so it's going to be multiplying by minus 1. And the 4 is already going to be multiplied by minus 1, so 4 volts. I'm going to just draw a normal here, so this is 4 volts. And this will be minus 6. So it's 6 volts, but the battery will be turned the other way around. So if I had drawn the battery like a traditional battery, these small sides here would be on the positive, on the upper side of this. So this here means it's going to be minus 4 minus minus 6. So F will still be 6 minus 4, which is 2 volts. Hopefully that that makes sense to you. I am wondering if there is a non-inverting amplifier that we can use to do this, but because it's times 1, the non-inverting amplifier is always larger than 1, and what we want here is times 1. It's harder to get it to with that one, but you can put in comments in case you know of a second design that complies with these, a third design that complies with these requirements. So this is solution 1 and this is solution 2.